Hello everyone, I'm Bree from the Singapore Management University. Today I'm here to introduce my proposal, Online Misinformation Detection in Live Streaming Videos. So with the development of the online platform, several kinds of misinformation is spreading across the platforms. So there are the text-based misinformation, the meme-based misinformation, or even the misinformation videos. So previously, people have proposed several methods to address this issue, but we claim a realistic misinformation detection setting. The misinformation detection in live streaming videos has not been studied yet. So previously, people have proposed some methods for the misinformation detection in videos, but the research has been done in an offline manner. So the system or the model will receive the whole video, and the model will predict whether the whole video contains any misinformation or not. But the difference is that the misinformation detection in live streaming videos should be conducted in an online manner. So what is the online manner? Instead of receiving the whole video, the model will only receive the video frame by frame. So maybe the first few frames are the neutral frames, but suddenly it comes to a second that the video is spreading some misinformation. So in conclusion, the misinformation detection in live streaming video should be done in an online manner, that the system will receive and process new video frame without any information from future. And the goal will be a bit different and beyond the accuracy of the detection. Because in the misinformation detection in the live streaming videos, we also requires the timeliness, which is that the model should detect the misinformation as soon as possible. So here is an example. The excellent system should detect the misinformation as soon as if there is a piece of information appears. But the system will also be a good system if it detects in a few seconds after the starting of the misinformation. And the system will also be okay if it catches the last few chance to detect the misinformation. So this is what we call the timeliness, that we want the system to detect the misinformation as soon as possible. But why should we study the misinformation detection in the live streaming videos? First of all, the live streaming videos play an important role in the propagation of the information, because we can see live stream videos every day around us. For instance, the live broadcast of the sport games, the TV news, the e-commerce product selling, the live sharing. And it is very easy for everyone to be a live streamer. So due to the two factors mentioned above, if there is any misinformation in the live streaming video, it will spread rapidly because everyone is viewing the live streaming video. And because it is easy for everyone to be a live streamer, there will be a great number of live streaming videos, and it will be infeasible for manual check. So it is very urgent to design automatic method for the misinformation detection in live streaming videos. A straightforward idea is that whether there are any existing solutions that we can leverage to address the issue, but unluckily the answer is no. So this is a brand new topic, but we try to find some related topics to the brand new task. So first of all, the related topic is the automatic misinformation detection. Previously, people conduct some direct check to compare with the piece of information inside the news with the facts in the knowledge base. And people have explored the styles of the information and the ways of the propagation. For instance, the misinformation may have some shocking titles or shocking articles. And the most similar topic is to our research is the misinformation video detection. But the difference is that instead of receiving the whole video at one time, the detection in live streaming video only receives the partial inputs. In other words, the partial video, and it requires the timeliness that requires the model to detect the misinformation as soon as possible. And the other related topic is the action detection in the live streaming video. It requires to detect the start of the actions as soon as possible. For instance, here, without viewing any frames in the future, the system is required to detect the action smile as soon as the action starts. And previously, people have adopted some frame-level classification method to address this issue. But as we mentioned previously, it requires more for the misinformation detection. For instance, we may need to do some fact-checking, the style analysis. So after introducing the task definition, the value of the task, and the related topics to the brand new challenge, next I will go through the way of constructing the dataset. I divide the dataset construction into 2 steps. First, I call that the video level annotation, and secondly, I call that the frame level annotation. But first of all, we need to have some video. So first of all, we do some video collection. The most straightforward idea is that we can reuse previous annotated datasets, specifically the datasets for misinformation video detection. And the good thing is that the labels for these videos are already available so that no annotation is needed. The bad news is that some of the videos may have been deleted already because they contain misinformation. But we can always do some manual collection and following the previous works. Specifically, we can choose the topics which are frequently related to the misinformation and collect videos under this topic from the online platforms like the TikTok or the YouTube. And next, with the collected video, we will do the video level annotation. So the video annotation will annotate whether the video contains misinformation or not. And the pipeline will be similar to the previous research study about the misinformation detection in videos. And first of all, specifically, we will train the annotator with a few examples to make sure that they understand the definition of the misinformation video. And finally, we use some majority voting for the annotation. For instance, if 4 out of 5 say, oh, it's a misinformation video, then the video will be annotated as misinformation. Next, we will pass the annotated misinformation to the next stage, which is called the frame level annotation. And in this stage, the video will be represented as a sequence of frames with the audio text. So for instance, like this. And the goal of the frame level annotation is to let the annotators to point out the starting and the ending frames containing the misinformation. For instance, here, given a video, the annotator should point out, oh, this is the starting point and this is the ending point of the misinformation. And we train the annotators as well. And during the annotation stage, maybe the annotation will be done by 3 annotators in 2 passes. And we need to guarantee 2 things. First of all, we need to guarantee that the annotation between different annotators do not differ a lot. And secondly, we need to guarantee the annotation from one annotator does not differ a lot in 2 passes. And we can use the Viper platform for help. And this platform is a very professional video markup tool. For the evaluation, I think the misinformation detection in live streaming videos should be evaluated beyond the evaluation metrics of accuracy. So previously, people have adopted the generic evaluation metrics for the binary classification, such as the accuracy, the macro, F1, something like that. But here, I want to emphasize the evaluation for the timeliness of the detection, so that if misinformation appears, we want the system to detect as soon as possible. So here we adopt the point level precision for evaluation. So it's like this. For instance, there are K misinformation spans annotated in the video. We want the model to detect as soon as the first misinformation span appears. And then let's assume the starting point of this misinformation span is SK, and the ending point is EK, and T is the predicted time. The prediction is valid if and only if its real distance from the starting point is less than the threshold alpha. And we want to encourage the model to detect as early as possible. So there will be a decreasement of the score if the model detects later. For instance, if it detects at the K misinformation span, it will only get the score like the gamma square K minus 1. And finally, I'll present some feasible baselines for the challenge. So as we know, the video contains different kinds of information. For instance, the video frames, the audio, the subscripts. So a very simple baseline is to convert all kinds of information into the text and feed the concatenated text into the system. So this is what I call the unimodal models. So here you can use the image caption tools to convert the image into image captions and concatenate the audio text and feed them into the text encoder, either pre-trained or not. And together with the history information, the classifier is trained to predict whether it is the start of the misinformation in the video. And the other thing is that we can also use some multimodal models. Instead of the conversion from the image to text, we can always directly use the image features from some pre-trained vision backbones and let them interact in some multimodal encoders. And similarly, together with the history information, the classifier will be used to predict whether it is the starting point of the misinformation. And obviously, here are some limitations of the previous baselines I mentioned, because they just regard the task as a specific case of the action detection in live streaming videos, but it ignores the characteristics of the misinformation detection. As we mentioned previously, the misinformation detection requires beyond the classification. So the model may need to do some fact-checking, style recognition. So better AI solutions are needed, and maybe more sophisticated AI methods should be proposed. So that's all about my proposal. Any questions?